So weather can go from calm to chaos in a flash. But the thing is, have you ever wondered how meteorologists predict the next big storm? Our next guest today is Meredith Wyatt from the National Weather Service, and her job is to keep 96 Georgia counties informed and to stay safe. So I almost want to say, Meredith, if the storm happened, I'm blaming you now. Is that what I'm trying to say? Or maybe not, right? But at least you predict and kind of warn me ahead. So she's definitely here to break down the science of weather and how you can stay prepared. So Meredith, let's talk weather. At least today it's beautiful, it's sunny, and happy STEM day to you.
Yes, happy STEM Day. So happy to be here. Thank you so much for inviting me. Yes, so glad that the weather turned out to be really nice today. Hope you all are enjoying the sunshine today because it does look like rain may make a return this weekend. So soak up that sun while you can.
Oh, look at
So,
that. We just had our first prediction. First, look, you've heard your first weather report right here.
all right. Well, I'm going to try to share my screen here. Let's see. All right, here we go. All right. Well, we will jump right in, you guys. The science of weather. Again, thank you so much for having me. So excited to talk to all of you about weather. Again, my name is Miss Meredith. I am a meteorologist at the National Weather Service in Peachtree City, just southwest of Atlanta. This coming October will be 8 years of me working with the National Weather Service. Prior to being here in Georgia, I've worked at the National Weather Service in Memphis, Tennessee, and the National Weather Service in Birmingham. So I've been traveling across the Southeast, providing weather and water information to many locations in the Southeast. So I wanted to start off first with this question: what is weather? So just kind of think about it in your head. What do you think when you think weather? Well, weather is a noun. It's the state of our atmosphere at a certain place in time, in space, generally with regards to things like heat or dryness, sunshine, wind, rain, things like that. And so here are a few weather words. So things that may come to mind when you're thinking about weather. Some examples: wind, clouds, temperatures, rain, snow, wind. Again, our weather is going to be that short term change in the sky. So, weather can change as quickly as a few minutes to a couple of hours to even a couple of days. Again, and that occurs at a specific place and time. So, what's your favorite type of weather? Do you prefer days like today where it's really, really sunny, blue skies, maybe some clouds out there? Or do you like active weather, hurricanes, thunderstorms, tornadoes? Do you like fog, things like that? At least for me, I do love thunderstorms. I'm really, really fascinated by lightning. I do enjoy, or not enjoy, I guess that's probably not the best word, but I find tornadoes really fascinating. While tornadoes and lightning can be really destructive and can be deadly, just really interested in the science behind each of those weather phenomena. There's a lot we know about severe weather like tornadoes and lightning, but there's also stuff we don't know. So just think about it. What's your favorite type of weather? So, how do we measure weather? You may be familiar with some of these weather instruments here. We're going to go through them from left to right. So, first on the left, we have a thermometer. So, that's going to measure our temperature. Next, we have a hygrometer, which that's going to measure humidity in the atmosphere. In the middle image is an anemometer. That's going to measure our wind speed and our wind direction. We have our barometer, which is measuring pressure. And then we also have a rain gauge. So that's measuring how much liquid water is falling at a specific place in time. At our office, we actually have a rain gauge out behind our building, and we check it every 6 hours. So, obviously today we're not expecting any rain, but it will come in handy this weekend in days where we have active weather just to see how much rain has fallen. And you'll also notice here all of these words, except for the rain gauge, have the word meter in them. And again, that's referring to a device or an instrument for measuring. And a couple of other ways that we can record observed weather. I'm not sure how many of you may be interested in this. I know we have some educators online as well. So, just some ideas for your classroom. You can make a weather journal or a weather chart over a couple days, weeks, months. That may be really interesting just to take note of the temperatures each day, morning and during the afternoon. As we know, we have the low temperatures occurring overnight and early morning, and then those warmer temperatures generally during the afternoon. Keeping track of when it rains or when it's dry, when it's windy. So, just kind of seeing those changes over time is really interesting. And then this image here on the far right, one of my coworkers actually created a temperature blanket last year. So, she actually took ranges of temperatures, so say 50 to 53 degrees Fahrenheit, and correlated that with a certain color. Um, and so she made her key and then went off of that. So each day she took the average temperature and then made a little square. So by the end of the year last year, she had created this weather blanket. So if you're really creative and you like making things, that may be an idea. If you're, like quilts or crocheting or things like that, you may be into something like that. Okay, so next we have what's called an automated surface observation system. So it's kind of a mouthful. We do like abbreviations in the weather service. So instead of saying this full term, we say ASOS, ASOS. Again, automated surface observation system. So, the ways that we saw that we could measure weather a few slides ago, this automated surface observation system actually brings all of those weather instruments together in a single unit. So, these ASOS systems are located at all major airports. So, we do have one at Hartsfield Jackson, one in Columbus, Macon, Athens, in those places. And again, all of these sensors are located together and help us observe weather. So they're very, very helpful when we're, again, observing the weather conditions across the state of Georgia. Moving on to a couple more weather tools that we use. Again, tools in our toolbox that we use to help us forecast the weather. We have our satellites. So, again, these are things that are launched up into space, basically big cameras that are taking photos and images of our Earth. So, as you can see in this image, we can see a bunch of cloud cover. We actually see a tropical system that is spinning in the Atlantic. This is not current. I'll preface by saying that this is an image or a GIF, I'm sorry, from September of 2022. So again, satellites really, really helpful at helping us see where the clouds are, where storm systems are. And next we have our Doppler radar. So that big looking golf ball type thing that you may have seen before. So our radar is going to show us where we have rain and thunderstorms moving through. As you can see in this looped video here, we've got line of thunderstorms and showers overspreading much of the state of Georgia. I think this was a few months ago, or I'm not sure when this was. Oh, this was back in 2017. I'm sorry. And then next, one of my personal favorites is our weather balloon. So we use weather balloons to measure our atmosphere, so get a vertical picture of what our atmosphere looks like. And so attached to the weather balloon, the orange parachute there, we attach that to the weather balloon. And then we also attach the weather instrument itself. Again, the thing that's going to measure different components of the atmosphere, and that is called our radio sonde there on the left image. We launch weather balloons at my office, again, in National Weather Service Peachtree City. We launch them twice a day, once in the morning and once in the evening. There are 122 National Weather Service offices across the United States, and 92 of those launch weather balloons. So they're really, really helpful, again, to see what the atmosphere looks like in the vertical. And we're not the only ones who launch weather balloons. Weather balloons are launched worldwide. So all of these little dots on this image indicate places where weather balloons are launched across the world. So really, really cool. Okay, so I do have a video here um, This is a video of myself launching one of our weather balloons. Again, we launch these twice a day, once in the morning, once in the evening. Right now, we're launching at 6 a.m. and 6 p.m., but when we have the time change this weekend, that'll be moved up to 7 a.m. and 7 p.m. All of this data we're getting in real time. We have a GPS system that is in the radio sonde itself, and that allows us to sorry, I was going to move this up a little bit, but that allows us to track the weather balloon and weather instrument in real time. So as soon as I let go of the balloon, we're already starting to get that weather data. um, the only time we do not launch weather balloons is during thunderstorms for obvious reasons. We want to be safe. We don't want to be in harm's way, but we do launch when it's really, really cold. We launch when it's pouring down rain, when it's windy, and obviously on clear days like today. So again, one of my favorite things that we do here at our office, it's an excuse to go outside and enjoy the weather and everything. So that is the weather balloon. Okay. Again, we launch our weather balloons are launched worldwide, so over around 1,300 balloons total. Again, 92 weather balloons launched in the United States from those weather service offices. A couple of other interesting facts: weather balloons can travel over 100,000 feet in areas where it's cold as minus 130 degrees Fahrenheit. So that's really, really cold. It's hard for me to imagine. And we actually do close to 950,000 flights each year, which that's crazy. So just a couple of interesting facts about the weather balloon. Another really cool video. This is one of my favorites. This is actually right before the weather balloon bursts. And as you can see the weather balloon has made it really, really far high into the atmosphere. And now it is coming back down. I'll play that again. That's a really cool video. And just another fun fact: most of the materials, I think the only thing that's not is part of the radio sonde or the weather instrument. Everything is, or the tools that we use, the string, the parachute, the balloon, are all biodegradable. Again, the only part that's not is parts of the weather instrument itself. So, a little bit about the layers of the atmosphere. So, weather happens in the layer called the troposphere. This is the layer closest to Earth. So, again, you see that's the lowest, 0 to 1 kilometers from the surface. Up to 12 kilometers is the troposphere. So that's where the weather happens. That's where we're concerned with. Me as a meteorologist, that's what we're looking into. Weather balloons actually burst in that next layer, known as the stratosphere. But we still have 120 miles or so worth of atmosphere left. So, a lot of atmosphere. Again, at least for me, we're focused on the troposphere, as that is where the weather happens. Okay, so question for all of you, just to think in your head. We're going to move on to clouds. Does anybody know what kind of clouds these are? Think in your head. You've probably seen them before. May go outside and see some today. I'll give you a second to think. These are cirrus clouds. They're made of ice crystals. There are high clouds, very thin, kind of wispy looking clouds. Next, we have these. I'm sure many of you know what these are called. I think of the movie Toy Story and the intro scene, seeing these type of clouds. That's what I think of when I see these. These are our cumulus clouds. So they're really puffy, like cotton balls, white and fluffy. And next we have clouds that blanket much of the sky. They're kind of hazy looking. They can be light, they can be dark as well. These are our stratus clouds. And finally, we have really, really high vertically building clouds. I'm sure many of you know what these are called. These are our cumulonimbus clouds. These are our thunderstorm clouds. And so, again, these are just our four main common types of clouds. There are clouds that can be kind of interchangeable, like cirrostratus, Cirrocumulus, things like that can be used interchangeably. But again, cumulus are low level happy clouds. Again, they look like cotton balls. We've got our stratus clouds, those are flat, hazy clouds. Cirrus clouds, thin, high, wispy clouds made of ice crystals. And then we've got our cumulonimbus clouds, which are our thunderstorm clouds capable of producing bad weather. Okay, so another question, how do we get weather? We've talked about all these different, components so far, but how do we get weather in the first place? Well, it all starts with the sun. It's as simple as that. And so as we know the Earth is a sphere. We know it's rotating on its axis, rotating around the sun. And so we know that the sun is heating our Earth, but there's an uneven heating of our Earth, and that's what creates our weather system. So you've probably seen some of these annotations here on this map, the big H and the L there. You've probably seen those on some weather maps if you're familiar. So we'll kind of talk about those. Again, uneven heating of the earth is what we get, or is what results in our weather systems. So, air moving from high pressure to low pressure, that moving of air is called wind. So, that blue H is our high pressure, cool high pressure. And our red L is our warm low pressure. And again, air moves from high pressure to low pressure. And that movement of air is what we know is wind. And so, thinking about it in the vertical, high pressure, so we've got air that sinks and moves away as it approaches the surface. And it's the opposite for low pressure. We have air converging or coming together and rising. And so, again, low pressure, we'll kind of talk about that here in a second. So, an easy way to think about this, high pressure equals happy weather. So, like today, we have high pressure centered across the southeast. So, that is promoting our dry weather for today. We do have some clouds out there, but generally it's going to be clear, maybe some high cirrus clouds out there. High temperatures during the day because again we have that sun overhead warming the earth, and then low temperatures at night. Again, if there's a lack of clouds, the conditions are going to cool really, really quickly. So again, high pressure equals happy weather. And low pressure equals lousy weather. So that's where the weather happens. We've got cloudy skies, we've got windy conditions, wet weather, maybe some thunderstorms, and then cold weather generally to follow. Okay, and you've probably seen some weather maps, or in school, or on TV. Sometimes TV meteorologists show weather maps with high and low pressure, and also frontal boundaries, namely a cold front and a warm front. So we're going to talk a little bit about those. So, when we're talking about cold front and warm front, we're thinking about different air masses. So, cold air versus warm air. And so, for cold fronts, you've probably guessed it, cold air moving in and replacing our warmer air. That's what a cold front is. And so, where that cold air and warm air meet, that boundary, that's where the weather happens. So, that's what you can see here in this animation. You see warm air rising up and over that cold air really, really quickly, and that warm air rising and condensing, creating clouds and likely producing some rain and thunderstorms. And then following the cold front, again, we've got that cooler air moving in and replacing that warmer air. And warm front, generally the opposite. So we've got warmer air moving in and replacing cold air. So warm air generally riding up and over our colder air. Again, warm front moving through, that's going to lead to rising temperatures, rising humidity, dew points. We'll see increasing clouds due to that increase in moisture, and maybe some rain and things like that. And so you've put that all together, that high and low pressure, your frontal boundaries, the cold front, the warm front, you put that all together and you've got your weather map. So you can look at weather maps now and see what kind of weather might be going on, not only in Georgia, but across the United States. Okay, so let's talk about thunderstorms. So thunderstorms, I'm going to use a different analogy here. So think about if you're baking something, you're baking cookies. Obviously, for cookies, you're going by a recipe. And just like you're going by a recipe and using all of the necessary ingredients, thunderstorms are generally the same way. Thunderstorms need certain ingredients in order to be formed. So the three ingredients for thunderstorms are moisture, a lifting mechanism, and instability. So obviously for thunderstorms, we need a moisture source in the lower levels of the atmosphere. So being in Georgia, we're in the southeast, so that's generally going to be moisture from the south or from our east. And then we also need a lifting mechanism, that push or that trigger that gets that lifting process going. And at least for thunderstorms, that's going to be your cold front or your warm front, as we saw in those animations. Again, that quick rising motion. Another way to think about this lifting mechanism is a car, or a golf cart, or a four wheeler. They all have that gas pedal. So think of that push that's going to propel that vehicle forward. So it's the same thing with thunderstorms. That lifting mechanism is going to push, or is going to be that trigger that propels that process. And then finally, we have instability, or is that ability of air to accelerate upward when it's given that push. So, again, back to the car analogy. So, yes, cars have the gas pedal, but you also need gas in the car so that when you push the gas pedal, it goes forward. So, that think of that as instability for a thunderstorm. So, again, we need moisture, we need a lifting mechanism, and we need that instability. All of that coming together, and that will give us our thunderstorms. And so, moving on to lightning, a component of thunderstorms. This photo was taken in Atlanta in June of 2020. So, interesting photo there. And I do have another really cool video. Now, this video is a really slowed down image of lightning. So again, lightning is one of my favorite weather phenomenon just because it's so interesting. It's, it's very quick. Obviously, we only see the flash. And so this video, we're seeing a race to see which of these little lines makes it down to the surface first, and whichever one does is the one that we see visually. Again, this is all slowed down a lot. And lightning, as we know, happens in an instant. So again, here I'll play that again. Yeah, so we see these branches extending down from that thunderstorm. So it's a race to see which one makes it to the ground. And whichever one does is that flash that we see, and that's followed by the thunder. Okay, so what happens when lightning hits the ground? Well, this is an image of where lightning struck the ground. I believe this is at a golf course. So really interesting there. And one interesting note, while we encourage, if there's thunderstorms around, if you see lightning, head indoors. That's the safest place you can be. You never want to be outside when it's lightning or when there are thunderstorms in the area. But if for some reason you happen to be on your way, to that safe place, we always say never lay flat on the ground, and this is why. Is because when lightning hits, it fans outward. A couple of other lightning facts: all thunderstorms produce lightning and are potentially deadly. Um, Unfortunately, we do see deaths as a result of lightning each year. We really try to emphasize being safe, being weather aware. Obviously, we're heading into springtime and eventually summer, and we know many of you are going to be outside at the beach, on the lake, at soccer practice, swim practice. So it's really important that you remain weather aware and knowing what to do in the event that thunderstorms move in or lightning occurs. Lightning can also strike 15 miles or more from a thunderstorm. So a thunderstorm doesn't have to be overhead for lightning to strike. Again, there's no safe place outdoors. Cannot stress this enough. We want you to be safe. If you, again, it's really important to remain weather aware, scanning the skies if you are outside and going indoors if you see thunderstorms approaching or even see, lightning. Okay, again, just a recap. When do we see that stormy weather? I'll give you a second to think about it. Remember that rhyme that I told you? Yes, we see stormy weather in low pressure. Low pressure equals lousy weather. Okay, a little bit about precipitation. So, precipitation is all liquid water or solid particles that begin in the sky and travel down to the ground. So, liquid water, i.e., rain, or solid ice, that can be hail, which hail forms in thunderstorms. We know that hail can be as small as a pea, but can also be as large as a golf ball, softball, or a baseball, and that's due to the strength of a thunderstorm. So you've got um, water droplets, ice crystals up in a thunderstorm, and the longer they're suspended in a thunderstorm in areas where it's below freezing, the larger they're going to grow. And at what point the thunderstorm is unable to hold those stones or those balls of ice any longer, that's the point in which they fall to the ground as hail. And then, obviously, going back to the weather balloon, this is another reason why the weather balloon and the data that we receive of our atmosphere is so important, is for us to denote what precipitation is going to be when it reaches the surface. Is it going to be rain, or is it going to be sleet, freezing rain, or snow? So knowing that temperature data, the dew point data, things like that is really, really important when we're creating that forecast. Okay, so a little bit about weather safety. So, again, spring is coming, summer's coming. It's really, really important to know and understand your severe weather hazards and know what to do in the event that we are forecasting them and sharing that information with all of you. And you check the forecast for your area or wherever you're going and see that those are potential things that could interrupt your time. So, general rule of thumb: tornado, hail, lightning, wind. Your action is to go inside. Go to a safe, sturdy shelter, generally away from windows. You want to stay inside during those. For flooding, again, your biggest thing, if you're in a vehicle, avoiding flooded roadways. We'll get into this in a couple of slides. But again, never drive through a flooded roadway, never walk into a flooded roadway. You want to be cognizant of those. So, as far as storm planning, again, so say a few days out, our forecast is calling for a potential for severe weather. So, say strong or severe thunderstorms, tornadoes, things like that. You want to make sure you know where your safe place is. If you're at home, know where you're going to go in the event that we issue a tornado watch or warning, which we'll get to that in a minute. You want to make sure you have plenty of supplies, have a flashlight, have a helmet, have your phone, have batteries, have things for your pets. It's important to incorporate your pets in your storm planning too, and making sure, again, you and your family have a plan for yourself. Know what to do if you're at home, if you're at school, even if you're on the road or traveling, and making sure all of you are aware of that plan. And then the day before, again, checking the forecast, checking for any updates as far as timing. Is severe weather expected in the morning, during the afternoon, overnight? That's important to know, and adjusting your plans accordingly. Again, ensuring you know where your safe place is, ensuring that place is clean and you have all of your supplies in there. And then the day of, again, remaining weather aware, remaining vigilant, knowing how to evacuate and get to your safe place quickly, reminding and making sure your whole family is aware of your safety plan. And when that warning is issued, that's when you need to take action. Okay, so watch and warning. So I don't know about you, but I love cupcakes. So again, I'm using another analogy to kind of bring this idea across, and hopefully it'll help you understand it a little more. So we've got a cupcake watch. So we have all the ingredients available to us to make cupcakes. We have not made the cupcakes yet, but we have all the ingredients there and they're ready. So thinking about a tornado or severe thunderstorm, we have all of the ingredients. Remember, we talked about thunderstorm ingredients: moisture, instability, lifting mechanism. All those ingredients available there. They haven't come together yet, but they're there. So that's the watch period. That's when you want to be prepared, and you want to again know where your safe place is. Take all of these precautions and be ready for the warning. So cupcake warning, that's when we put all of the ingredients together. We put our cupcakes in the oven, and boom, we have cupcakes. So same with thunderstorms, tornadoes. All of those ingredients have come together, and the thunderstorms are imminent. They're happening. So again, that's the watch and that's the warning. Watch, be prepared. Warning is your take action. And so, speaking of your safe place, in this image, in the green areas are the safest place to be. Safest place to be, you want to be in the lowest level of your home, interior room with no windows. We know many people have basements. If you do have that, highly recommend. Great place to go. If you don't have a basement, an interior closet or a bathroom with no windows. We get a lot of questions about um, mobile homes. We know that that's a thing here, especially in the southeast. We really really emphasize again the importance of planning ahead and making sure you're again weather aware several days out. If you're hearing about the potential for severe weather, if you have friends or family in if they don't live in a mobile home, if they again live in a neighborhood, have a basement, make plans ahead of time, to be able to go there while that severe weather is occurring. So again, um, we do get those questions a lot, especially given many locations across the southeast have mobile home communities. Again, you want to be in the lowest level of your home, interior room, no windows. That's the best place that you can be. And as we know, in Georgia, tornadoes can occur at any time. Severe weather can occur at any time. And oftentimes they do occur at night. And that can be especially hazardous, one, because most of us are getting ready for bed or already in bed. And obviously it's dark outside, so we can't see. We have a lot of trees out here in the southeast, rolling hills. So if you were outside, severe weather, thunderstorms, tornadoes, things like that, are already hard to see at night as well. So again, if we're expecting severe weather to occur overnight or in the late evening when it's getting dark, again, that's your cue to make sure your safe place is ready. It's a good idea to have flashlights or shoes, make sure your cell phone is charged and all that is ready to go. So in the event that a warning is issued, you can get up and head to your safe place in a matter of seconds. Another good option is your NOAA weather radio. These are actually tested weekly to make sure we issue a test for the weather radio, and they're again issued. The tests are issued weekly to ensure that everything is running properly, that you're able to hear the test and things like that in the event of the severe weather. So, a little more on lightning and thunderstorms. One thing we like to say is when thunder roars, go indoors. Again, we want you to stop all outdoor activities, or we encourage that in the event that thunderstorms are moving into your area. Again, we want you to seek shelter in a building, something sturdy. And generally, a good rule of thumb is to wait around 30 minutes until you hear the last rumble of thunder before you resume your activities. Another interesting fact about lightning is hotter than the surface of the sun and can reach temperatures around 50,000 degrees Fahrenheit, which that is crazy. So again, lightning, very, very interesting weather phenomenon. It's important to know the hazards and risks associated with lightning and thunderstorms so that you can best be prepared. A couple more lightning safety tips. Another slogan we like to say, it's this little diamond shaped image there on the left, is if you see a flash, dash inside. So another little slogan we do enjoy is, in addition to our acronyms, we do enjoy slogans in the weather service as well. Again, safest place you can be in a thunderstorm, or if thunderstorms are occurring, indoors. Again, until 30 minutes after that last clap of thunder. If you are on the road, or if you happen to be, headed to the store, headed back from the store to and from school, again, If you're on the roads, remain in your vehicle. That's the best place that you can be if you're not at home. And again, we do not want you to be outside when there are thunderstorms, when there's lightning. Lightning is looking for when it, remember, we saw that in the very slowed down video of lightning traveling down and making contact with the surface. Lightning is looking for that tallest item or that tallest thing that's out there, and we don't want that to be you. So don't shelter under trees in an open field, anything like that. Again, if you're unable, for some reason, if you're unable to get indoors or in a vehicle, you want to make yourself as small a target as possible. And then going back to flooding, very, very important to stay out of floodwaters, as they can hide dangers that, can be impactful, negatively impactful to all of us. There can be animals, insects, sewage, sharp objects, live wires. You never know what's in floodwaters. So please remain out of those. And finally, some other safety tips. This is an image from Troup County, Georgia, from weather that moved through in April of 2019. It has washed the road away. And so that's another important thing. If you're in the car with friends, family, your parents, really, really important. If you see a water covering a roadway, please do not drive through it. Another slogan for you: when turn around, don't drown. And so, again, if you see water over that roadway, please don't drive through it, especially if there's barricades, because you never know if that road has been washed out. You don't know how deep the water is. It only takes 6 inches of water to move a vehicle. So please remain aware of that. And again, you don't want to walk, stand near floodwaters or cross the roadway. And finally, here are some resources. I know we have students and educators alike. I think these may have been shared prior to this event. The first one is a link to our local National Weather Service page here in Peachtree City, with specifically for outreach. So good resources there. We also have Sijinx and Jetstream, which I would highly recommend for educational content, videos, games, and just all the things that we talked about in this presentation and more. Everything is free. Highly recommend that you check those out as well. So if you'd like to take a photo of those, you can do that now. Again, thank you so much for having me for today. Love doing these type of things, just sharing, just talking about weather. I love weather. I'm a weather weenie. And finally, again, thank you so much for having me. Are there any questions?
Oh, they got questions for you, all right.
Oh, goodness. Okay, here, I'm gonna.
So I'm gonna start with the easy one and the fun one. Deborah asked, "What is your favorite season?"
Ooh, I love fall. I love fall. I love, even though, fall's probably better up north, just with, cooler temperatures and stuff and the foliage. But no, I do love fall. I love cool mornings, cool, foggy mornings.
I'm
So,
the opposite. I like me some
oh,
summer. I'm an island girl. I like the summer. I need to be. I need the sun. I need the hot. I need the sweat because I
okay.
don't exercise, so this is the only way I can sweat out. So yeah, for me, it's the summer. The
Oh
other
my goodness.
question, and I'm sorry, Cabra, if I don't want to mispronounce your first name. They asked, "Can you survive a tornado?"
Yes, we have seen people who have, survived tornadoes, and it's always interesting to hear, survivor stories. And just an interesting thing about the Weather Service: our job is not done once hazardous weather or the weather has cleared. We actually go out and survey storm damage. So we're the ones who determine. I know I didn't mention it in this presentation. We can go on and on talking about weather, but but I'm sure many of you have heard of the EF scale, or the Enhanced Fujita scale, the EF0 to EF5. So we're actually the ones who determine that rating. So, and that's based on damage points. And I have personally, spoken to people who have, survived. It's very, very sensitive, and we have to, in some instances, set the science part aside, even though we are there for a purpose and, empathize and sympathize with that individual. But yes, it's generally those people, we talked about our safe place, knowing where those are, where that is in your home. And their survival has been because of that, because that they took action, they were prepared and knew where their safe place was.
Okay. And Adair wanted to know, how are you all using AI to make predictions or generate alerts that people get on their phones?
Yeah, so I am not, at least in our office, we're not directly doing that right now. There are parts of the Weather Service dedicated to, and trying to utilize and incorporate some of that, and eventually, following testing and things like that, that will be, delivered to local offices. So that's
Okay.
a great question.
And then the other one is, how or does daylight saving, because this weekend is time is changing this weekend.
Yes.
So we're springing forward. So this is a great question in terms of how daylight affects weather.
Yeah, no, absolutely. It's a great question. At least from like an operational standpoint, some of our, timing of, when we're issuing products, will change, and we got to keep in mind, the time change, making sure we, get to work on, right time, just because we're shift workers. But no, like definitely we are, moving from winter to springtime. And so, more daylight, more opportunity for some active weather. So we'll see what awaits us this spring as far as severe weather season. So that is coming up. So we talked about thunderstorms, tornadoes, things like that. So that'll be interesting to see for sure.
Okay. Then the other question is, what type of classes or courses do you advise students to take if they wanted this type of career?
Yeah, absolutely. So we are very math and science heavy. Most of us have gone, at least for the weather service, gone to school for meteorology. Um, at least for this type of field, again, encouraging, math and science. And I want to preface by, you don't have to be, an expert in these fields. At least for me, I love math. Math was probably one of my stronger subjects, but science, while I was good at it, it was probably one that I had to work on a little more. I wasn't like the best star student. So, if you do struggle in one of those subjects, please don't let that, keep you from wanting to pursue a career, in the science or, weather um, field. You don't have to have, the top grades or anything to achieve that. But yeah, definitely math and science. Even like public speaking or type of communications type classes are also really good. While we are behind the scenes, again, we're not on TV, we're not the TV meteorologists. We do communicate with the general public. We'll get phone calls from people. Hey, what's the weather in Macon, Georgia this weekend? I'm have an event that I'm doing. What's the weather? So we talk to people on the phone. We talk to emergency managers. We do talk to the media on occasion, and doing things like this where we're talking to students and educators, just general public about weather. So having good communication skills and things like that is definitely not a bad thing to have as well. And just anything else that you're interested in too, whether that be I know we this STEM day has talked about programming, maybe GIS and all these other things. Anything else that you can add, I think that would be amazing.
Okay, I have I have a question for you, and
Yeah.
this is again with the technology. I'm curious to know what advancements that you've seen, if for that you see in the future for meteorologists in terms of when it comes to technology, or like what, because I've seen, and I'm sure other folks have in the news. It's like, okay, we have the newest Doppler radar 2000, and we have. I'm like, okay, that sounds exciting, but can you tell me when the weather is going to happen? I need to. So,
Yes,
can you
yes.
talk about some of the advancements in the future of meteorology?
Yeah, no, it's really exciting just because, as we know, technology is always advancing and things like that. And, more notably in the 90s and, early 2000s was that, transition, in radars. We got the Doppler radar now and all this new, data that we're getting. And so, that was a big thing then. And now, we're moving into, um, we've got social media and apps and, all these, different things, and trying to adapt, is definitely something that, the Weather Service is kind of thinking about, you know. And so, I definitely think that I know the previous question, is talking about what can I do in school to prepare
Mhm.
for a career like this. Well, going back to the communication, I think we are doing a lot more communicating, with like emergency response and officials, and, providing, being there in person, providing that weather information. So I do see us being more, having, more communication, with public and with people who are making certain decisions for things based on weather. So I do that, for me at least, is where I do see us migrating more towards, where in the past it wasn't so much that. It was, kind of being in the office doing the forecast, and that's really it. So we are kind of, migrating in that direction.
And I'm probably gonna age myself. I do remember growing up watching the TV, and the folks were giving the news. They had these little cutouts that they had to put on the map, or like a U.S. map, and say it's gonna be sunny down in Florida, whatever. It's gonna be. That just tell you how old I am now. It's like with a click of a button, and especially with, because I used to work in the news business, so I know in terms of what goes on behind the scene. And then when COVID happened, you had folks that was able to tell the weather from their house, right? They could tell the weather. All it was because of technology. So you can imagine, from a cutout on the map to now being able to broadcast the weather from your home, because we were at code during COVID that time. And 10 years from now, where are we gonna predict the weather? What other equipment that we're gonna be able to be available to use to
Absolutely.
predict the weather. So this has been an amazing conversation. Thank you so much, Meredith. Please go ahead, y'all. I need y'all to give a little clap in the chat for Meredith.